Alright, so this video is going to show you how to solve for
analyze
vector components. I have redrawn my 12
So the first thing that you need to do is you need to make sure that you have
vector
access to your
at
video.
60
So whatever
degrees
video
above
you're
the
going to
positive
use, whether it's
x-axis,
your
right?
boat
Here's our
rolling or
x-axis
someone else's
up
boat,
here.
excuse me, not
Here's
rolling,
our
floating.
y-axis up here.
You need to save it
So just
somewhere that you can get to it.
Reviewing a
Either
little
the
bit of math,
desktop
you
or in
know
a
that
folder,
this is 60,
somewhere where
this
you
is
know how to
30
access it.
degrees
If you
up
haven't
there.
done that,
But
push pause
you
on the
can
video, go
work it
save it to your
backwards with
desktop,
this
and
angle,
then come back.
and you should get the same answers if you want to double
Okay,
check.
so now that you've
Try
got that
free throw
saved,
shot. So
we're
what
gonna
we
go
need
ahead
to
and
do
open
is
up
we're going to try and
Logger Pro.
figure out the x
When
component
you open up Logger Pro, it's going to look like this. It's got a
of
blank
this,
data set chart
as well
over here and
as
a blank graph.
the
And it's just
y
waiting for the data
component.
So what we're going to do is we're going to insert a
of
movie. So we're going to
this
go up here and click
particular
on insert.
course.
And we're going
Okay.
to come down here and
So,
do movie.
in order to do this, we're going to use our
Now
trig
you have to
functions.
go back to that video wherever you
And
saved
we've
it.
got
I
to
saved
see
mine
that
on
this
the
is a
desktop,
60
so
degree
I know
angle.
exactly where it
So
would be.
this is going to be our
Yours
opposite.
may be in a
and
folder,
this is going to be our
wherever it
adjacent.
is. Go
We'll start
find
with the
that
X
video.
since I got my orange
Click
pencil.
on it.
And so what we've
And
got,
insert.
if we're using
So
adjacent,
take a minute right now,
we've got
pause the video,
angle,
go do
and
that.
we've got
Make
the
sure that you have your
hypotenuse
video uploaded.
with our
When you've got it like this,
SOHCAHTOA.
then you can come back.
SOHCAHTOA.
Okay, so now we've got our
up here.
video uploaded.
I've got the
into
hypotenuse.
Logger Pro, and this is where it gets pretty
I want to
slick,
find the
'cause it starts
adjacent,
to graph
and I'm
all
given
this
the angle,
stuff
so I'm going
for
to
us.
use cuff. So I'm going to say
So what we need to do
cosine of theta
is first we need to push this little button right here with the red dot.
adjacent
Enable and disable video
over
analysis. Let's
hypotenuse.
enable it, and that's going to give us these little buttons
I guess
over
I should
here.
put our
The
theta
first
in
one we're
blue,
going to use is this
since it is
little
also
ruler
a
right
given.
here. It says set
So
scale.
now I'm just going to go and I'm going to plug in
and
my
all
numbers.
that does is it tells this picture.
Before I do this,
How
though, I'm going
long
to go ahead
is
and
this?
rearrange
Is
the
this a
equation
foot?
so
Is
that
this
you
a
see.
yard?
So to
Is
get
this
adjacent
a
by its
mile?
side,
Is
that's
it-
what
what
we're
is it?
solving
So we have
for.
to set
F
the
sub
scale
x.
for the video because
I'm going to multiply both sides by my hypotenuse.
Up close shot. So we need to tell the screen.
And so
what
I
it
have
is.
hypotenuse
So
times the
we'll click
cosine
on
of
this,
theta
then we'll come
equals
into our video and we'll
my
measure
adjacent.
something that we know. My ball,
Now I can plug in
is
the
going to roll
variables that I
across
know.
here, but the height that I know is the height
12
of this little shelf
newtons
right here, and I know that
times
this shelf.
the
So I'm gonna
cosine
click and then drag
of theta,
down to
which
the
is
bottom, and it's
60
gonna get my little
degrees.
green
Make
line
sure that
there.
your calculator is in
And I know that
degrees,
that shelf right there
is
is
equal
7
to
inches. So I'm going to type in 7, and as soon
the
as I
x
put the green
component
line on there,
of that.
this box
now,
showed up.
I'm
I
gonna
didn't
go
have to
to my
click on
calculator.
anything; it just pops up. So I'm going to go 7.
And
I'm going to make sure that I
say
change this to inches.
60 degrees.
So now the screen's going to say, okay,
of 60 degrees
this little
is
green line is
0.5
7 inches. Anytime anything moves this far, whether it's this
times
way,
12
way,
newtons
whatever direction it moves, whenever it goes this
equals
far
my
across
f
the
of x.
screen,
So I
that
know half
equals
of
7
12
inches. And that's what we call
is 6
setting the scale of
newtons
the video.
equals
So take a second and do that if you haven't done so already.
f sub x.
Alright, next
F
thing we
sub
need to do is we
y,
need to get this ball in the movie so
I'm
we
now
can
going to have
start
to
to
use
analyze
my
it. So I'm going to hit play here. There comes the
sine,
ball. So I'm going to
because
stop
looking
it.
for the opposite.
Clicking
right?
on this little
F
thing
sub
right
y
here
is
allows me to
opposite our angle.
rewind the video and fast forward.
So
I'm
I'm
gonna
going to do
rewind.
the same
That's
thing,
not
and you
us
could
only.
basically, if you once you start to
The
do
ball
this a
until
couple
it
times,
just
you'll realize
starts
that
to come into
really
the
all you're
screen.
changing is sine and cosine.
Notice it's
depending on
not
if
the
it's
beginning of the
adjacent
video.
or
All
if
this
it's
is kind
opposite.
of trash, really.
And in this case,
All we're interested in is
we're
when the
gonna look
ball
for
actually
so I'm going to say
excuse me, rolls across the screen.
12
Notice my reference is moved,
newtons,
but that's okay
which is our
because the screen
hypotenuse,
still knows
times
this
the
distance
sine
is 7 inches.
of theta.
So now I'm going
which
to
is
set
60
my x and y
equals
axis.
f
Go up
sub
here to
y.
where it says set origin.
So again, I'm
gonna
going to
click on that.
calculator.
And that gives me
60
now an x and y
sine
axis. I'm going to pick
is
some spot on the ball
0.866.
that's
I'm gonna
easy to
multiply that
identify.
times
I could
our
pick the middle of the
hypotenuse,
ball, but
which is
sometimes I
12
might
newtons.
click here,
So I'm gonna
sometimes
get
here, sometimes here.
10.39.
So I'm going to click the very
So
front edge of the ball, halfway up.
10.3
And I'm gonna click.
newtons
Notice that sets my x and my y axis.
is the y component.
If it's not perfectly in line with
Both
where the
of
ball is going to
these
roll, then I can click on this yellow dot right here.
combined
If I click
to give us a
and
resultant
drag, it lets
vector, we
me
call this a
rotate this
resultant.
axis
Resultant vector of
to
12
however
newtons
that ball is moving.
at 60 degrees.
This one was pretty close. So
What
I'm
I
gonna
encourage you to
move
do is
back
flip
right
it,
there.
and now
I'm gonna leave
use
it here.
this angle
Take a second and do that.
as 30 degrees.
All right, now that you
Pay
got that
close
finished,
attention to what
now
you're
we can
doing
start
when you
setting our
solve
data
for it.
points.
Now our
So,
y component
This right here, add
is
point.
adjacent, so we're going to use the cosine for the y,
No, I
and
don't
our
want to
x
do that.
component is opposite,
Sorry about
so we're
that.
going to use sine for the x.
I'm going to click
See
on
if you
this
can
little
do it for this
add point
angle
right
to
here.
reverse this process,
And I'm
you
gonna
should
start to
come
add
up
my
with the
data
same
points.
answers.
Each data point is going to be at the
Before we
very
leave this
front
problem,
of this
however,
ball. ask yourself, does this make sense?
And when
if it's at 60
right
degrees,
now the mouse is just hovering
more
over
than
it. When I
45.
click now, it's going to set
should the
that
X
data
be greater or the Y?
So watch what happens here.
Well, if it's more
I
than
clicked it,
45, the Y should be
and a
greater.
couple things happen.
More of the force is in the up
One,
and down, and of
it
course
advanced
it
the
is.
frame. Notice the ball moved.
So this passes
So it went
the
to the
common
next
sense
frame. As soon as I clicked
You can
there,
move on to
it
number 2.
advanced to the next frame for me.
3, 4. Keep on.
It
working.
also
I'll put
came
the
over
answers on
here,
and
it put some data in our data chart. And so if you see here, at time equals 1.4 seconds.
If you have not solved the
so at time
2 through 4,
1.4 seconds,
you need to go ahead and hit pause on the video. I don't want to spoil it with
X
all the right
position
answers.
was 0.
If you have finished them, here come the answers.
And my Y position was also 0.
For number 2,
so when I put the point here, it automatically throws it in the data chart.
newtons,
and
F sub X is negative 14.09. Make sure that you have that negative because you think
that it plotted
the force
that
is
point
to the
on
left,
the graph.
right?
So what I'm going to do is I'm going to plot
the
the
negative
points here.
x-axis. So we got to symbolize
come back
that
to the
force
front of the ball.
is to the left. There's your negative sign.
I'm going
to
to add a point, and it
Number
advances
3,
again.
X
Add a
component
point,
of 12.5 newtons.
again.
And Y component
Now some of your
negative
boats don't move too fast.
21.65.
So here's what I suggest.
The Y is now negative because it goes down on the Y-axis.
That you
negative
advance a
down.
couple frames. So instead of going
the
just
last
to the next
one, number
frame,
4, has
2,
an X component
3,
of negative
4,
9.65
5.
newtons.
Let's go 5 frames.
And a Y component of negative 2.59 newtons.
And put it
on each of these. Make sure that you're showing all the work so that I can
1,
correct
2,
it if you're having
3,
errors.
4, 5.
We'll move to the back
frames
now and do a problem there.
And put a data point.
Okay,
1,
so on the
2,
back,
3,
we've got problem
4,
number 5. A person pulls a
frames.
50 kilogram desk with a 200 Newton force acting at an angle of 30
and
degrees.
notice as I'm
above
putting
the
more points in
horizontal.
here, they're
the
loading
desk
over
does
here,
not
and they're also
budge.
plotting
Draw
on the
a
graph.
force diagram for the
So
desk.
take a couple minutes and do
couple
that.
new things here.
I'll be sitting
So
back here doing
we'll start
it
out
as
with
well.
our free body diagram. The desk will be represented.
I'll let you know before I
as a
change. So you
particle.
can actually just let the video
Obviously,
go.
we know immediately that there is a force of gravity.
It's like
pulling
we're
down on
plotting
that
these
object.
points together, except
Force
I'm doing
of
this rolling
gravity.
ball and you're doing a boat.
And we're not sure
Like
exactly
in the
what
same
that
room.
is yet, but we'll get to
But
it in
we're
just a
not.
second. We also
I'm in
know
school.
that
You're at home.
this person pulls on it
There's proof that I'm at school.
with a force of 200 newtons at 30 degrees above the horizontal. So if this is our horizontal, this person pulls on it with some force of the person at 30 degrees above the horizontal. Now, it says the desk does not budge, so that should be a little warning sign that something is holding it back. So here we're going to have this something holding it back, and after our discussion the other day, that something is friction. If it's not
I've
moving,
got my
that
points.
is static.
If you don't have your
friction.
points, go back to the video, hit pause, finish up all your points, and then come back. So hit pause if you aren't finished with your points. Okay, now that you got all your points put in, we now see we've got a bunch of points on our chart over here, and we also have a bunch of points across our screen. Really, we're done with the video now. We've gathered all the data that we needed to gather, so we don't really need that anymore. I'm going to click on the graph just to get the movie out of there. If you want that movie back, just shrink, come up here to the corner, shrink this down, and you can pull that video back to the front. Okay, but I don't need it right now, so I'm just going to focus on my graph. Alright, so you see a couple of things here. We see the Y is plotted in blue and the X is plotted in red. This is making sense, right? Because how does our position in the Y direction change? As it goes, the ball rolls across the screen, really it doesn't go up or down. It basically stays right on that axis. So that's stays on the 0. As time progresses, the Y stays the same. Now, as time progresses, though, the X changes. It goes a little bit each time. And so, this goes down. We talked about this a little bit in class. This negative slope. Basically, all this is telling us, remember, positives and negatives just tell us direction. So, if it's a negative slope, that means that it's moving to the left or it's moving down. It doesn't mean slow or fast. It just means moving left or moving down. In this case, you could probably answer, the ball is moving to the left. The other thing that we notice is this line is basically linear, meaning it basically makes a straight line. And that tells us a lot, right? Because the slope of this line, as we've talked about, the slope of a position versus time graph tells us the velocity. If this is a straight constant slope, that means it's a straight constant velocity. So we can analyze these data points to figure out what the velocity of this thing is. Here's how you do it. You come up here to analyze, then you come down to linear fit, and we want to do a linear fit on the X, and we hit OK. Do that now if you haven't done it already. Just go analyze, linear fit, X. Hit pause if you're not finished. Alright, now that you got the linear fit in there, you can see how this point out here is kind of an outlier, right? It doesn't fit on the line. Most of the rest of them fit basically on this line, and so we call this a best fit line. And it gives us our y equals mx plus b. X is our y in this case because it's moving across the screen. M is our slope. X is on the x-axis is our time, and b is the y-intercept. M is our slope, and if you notice here, this thing is rolling at 20.6 inches per second. Don't show this again. Okay. 20.6 inches per second. And so the speed of that ball as it rolls across the screen is 20.6 inches per second. The velocity is negative 20.6 inches per second because that means it's moving to the left. And so there we have the velocity of this ball as it rolls across the screen. Just to drive this point home, let's come up here and let's do analyze linear fit of the y. And what do you think the slope is going to be, or what do you think the velocity is going to be in the y dimension or in the y direction? Answer that out loud. Say it. Say it out loud. Okay. What do you think it is? I hope that you said 0. And look, it is. It's pretty close to 0. It says 0.8 inches per second. That's probably because of this puppy right here. We bring it back in here. Look how much it comes down. It goes to 0.25 inches per second. That's not very much. The velocity that it has is probably because of old shaky hands back here holding the camera and moving up and down as the ball rolls across the screen. So that's how you do a linear fit or a video analysis of an object moving. If you have any questions about this, you can always rewind, rewatch, and retry. Hope you enjoyed it as much as I did. Toodles.